Hello and welcome to Algebra 2, Chapter 8.1. So this is our first section in Chapter 8. And Chapter 8 is entitled Exponential and Logarithmic Functions. So these are new to our discussion of functions. 8.1 in itself is called Exponential Growth. So what is an exponential function? How is it different from what we've discussed before? So an exponential function is going to be in the form y equals b to the x, where the exponent is a variable. So everything we've done so far, the base has been the variable, the exponent has been a constant. And so now we're going to get up into the exponent being a variable. So what I have graphed for you here, this is y equals 2 to the x. Okay, so this is the general form for an exponential function. And we need to bring up the word asymptote. And an asymptote is a line that the graph approaches but never crosses. And so you'll see that this graph gets closer and closer to 0 or to the x-axis, but it's never going to cross that. And that's because an exponent isn't going to change a positive number to a negative number. So if we just made a quick table, 2 to the, it's not a 2, let's try one more time. 2 to the 0 is 1, which is where we find ourselves right here. And then, obviously, if we go to the right, everything's going to be positive, but 2 to the negative 1 is a half, and 2 to the negative 2 is a fourth. 2 to the negative third is an eighth. And what's going to happen is that we just get closer and closer and closer to 0, but we're never going to cross that. And so that line that we get so close to, it's called the asymptote. So graphs of exponential functions. You always want to start with the y-intercept. And so that's easy to put in. You just put in 0 for x and you have your y-intercept. At the moment, the x-axis is going to be our asymptote, but it's not always going to be our asymptote because we can shift this graph up and down just like we've shifted all of our other functions. Domain is all real numbers because it's going to continue to go left and right the entire time. Now for range, the y is going to be greater than 0 if a is greater than 0, or y is going to be less than 0 if a is less than 0. Meaning if this actually turns up like that, or this turns down. Okay. And so these characteristics are true only for y equals ab to the x if a is greater than 0 and b is greater than 1. Okay, so something to keep in mind there. And these are called exponential growth functions. So let's actually graph one. So here we have y equals 2/3 times 3 to the x. And you're going to graph these the way you've graphed anything else, and that's by making a table. And I would always start with 0. So if we put in 0 for x, 3 to the 0 power is 1. 1 times 2/3 is going to be 2/3. Okay. And for the sake of me not being able to draw a dot where 2/3 is, I'm just going to count by thirds. We'll count by ones on the x-axis. So 0 2/3 would be there. And then if we put in 1, 3 to the 1 is 3. 3 times 2/3 is 2. So you'd get up to 1, 2. And if we did negative 1, 3 to the negative 1 is 1/3. And then you'd get 2/3 times 1/3, which is going to be 2/9. So that's 2/9. So, okay, and so then what's going to happen is that this graph is going to come down like that. And you need to make sure that you don't cross the x-axis, okay? And there you go, you have a graph. Now, that was the base, we'll call it the parent graph. That's what we've called it before. But you can then shift the graph, okay, just like we've shifted our other graphs. And so, here's our parent graph, okay, and so that takes that first part into consideration. But then if we have this minus h or a plus k, that's going to shift us left and right, up and down. Now that minus sign has been present all year, so remember that one is going to be the opposite of that. So if it actually says minus 3, you're moving to the right 3. And then the plus k at the end moves you up and down. So if we look at this, we're going to start out by actually graphing this function. And so you might just do what we did with the square roots and the cube roots and plot a few beginning points. And so if we start with 0, and we put in 0, we're going to get 2, so we get 0, 2. And if we put in 1, we get 6. So we get 1, 6. And let's go ahead and put in negative 1, and we're going to get 2/3. So you get these points to begin with. And then if we look at these other shifts, we're going to go right 2, up 1. So if we take both of those points, right 2, up 1, we end up here. Now, the asymptote to begin with was the x-axis, but that shift up 1 shifts the asymptote up 1. And so now you're actually going to come down along y equals 1, and you're not going to cross underneath it. And that's where it gets to be really important that you know where those asymptotes are so that you don't cross them. Now it does say to state the domain and the range. The domain is going to be all real numbers because it goes left and right forever. Range is going to be y greater than or equal to 1 because of that shift up 1. Okay, so these do have some real-life uses, and so here's just one of them. When a real-life quantity increases by a fixed percent each time interval, you can use this equation, y equals a times the quantity 1 plus r to the t power, and make sure that you write down what everything there stands for. So this, maybe this is the example that college tuition goes up by 5% every year. Or maybe you do have a bank account that maybe some sort of simple interest that you're making 5% interest per year. And so this would model that kind of situation. The other situation for growth models that we see every day is in compound interest. And so here's your compound interest equation and what all those variables stand for. And compound interest is earning interest on your interest. And so if you have a savings account, and hopefully maybe you're earning interest every month on that savings account, and so the interest you earn in January gets added to your account, and then in February you earn interest on that interest you earned in January. And in March you earn interest on your interest from January and February. And so that's why it's called compounded, because it continually adds up. And it's a great way to more quickly earn money, or in the downside to that, more quickly have interest you have to pay on your bills. So, but here's your compound interest equation so that you can have that written down and know what those variables stand for. All right, that's all I wanted to go over in 8.1. Let me know if you have any questions, and I'll see you in class.